and instead go back to this real quick. All right, so basic announcements. I mean, really, you guys, you just turned in your last homework. Moksha is working through homework D2, and we'll have homework D2 and D7 graded by the end of the original finals week, because I have to turn in grades after that. Anybody with an honors contract, I've already kind of, I think, sent you an email reminder about, basically, I think the Friday of the original finals week. So next week, then if you get me your contract submission by then, so I can grade it over the weekend, then that would be great. So not this Friday, but a week from this Friday. So the only other assignment you have, there's a muddiest point at the end of this week. So that muddiest point is just sort of an opportunity for you to reflect either on the final exam, if you are in the early group and took it there, or the whole class, things that you thought were clearest, things that your class still came out kind of muddy, and things that you might look forward to learning more about in future classwork or future studies. That would be great. So that muddiest point you do have, but then otherwise it's just the final exam. Everybody by default is going to be in this early group. So today is the last day to elect to move into the late group if you would like to. So if you want to move into this late group on Canvas, click on People, and then there'll be a tab that shows up at the top, Groups. So then you can click on Groups, and then you should see both the early group and the late group show up there, and there should be a little join button next to the late group, and you can feel free to join that. The other thing to make sure you do on Canvas is to make sure to take that final exam compliance test. Just like we had a midterm exam compliance test, you'll need that in order to access the final exam module, which has a bunch of study resources in it as well. So make sure that you take that final exam compliance test as soon as you can. Make sure that your lockdown browser is still working, and then also give you access to all of those final exam studying resources, and then eventually the final exam when your section becomes available. So again, today is the last day, and then I'll answer that question in a second. Today is the last day to choose your group. Once you've chosen your group today, then sometime tomorrow I will create the sections so that one of the virtual sections will be assigned to final exam Thursday, Friday of this week, and then the other one will be Monday, Tuesday of next week. And just so you remember the timing, hypothetically, if you're in the early group, then Thursday, early Thursday morning, so like Wednesday at midnight, so early Thursday morning, then the stage 1 exam will become available, and you will have all day that day to start the exam. And so whenever you start it, you'll then have 90 minutes to finish it. You have to finish it during the 24-hour period. So that's the only, if you start it, right at the end, it might cut you off early. But as long as you give yourself 90 minutes, you can take that 90 minutes anytime throughout that day. You'll take it with Respondus Lockdown Browser plus Monitor. That will be a closed book exam, but you are allowed to have a note sheet identical to what we did in the midterm. So I think I've written this somewhere. I think it's in the syllabus to be clear. So let me just make sure I don't misquote myself. And so what I'm doing right now in the background is I'm opening up a copy of the 325 syllabus so that I can make sure that I tell you on the final exam, you are allowed two-sided or 4 one-sided handwritten or hand-produced sheets of notes and several sheets of initially blank paper. And so I will just copy and paste that from the syllabus right into the chat. So that's that. And so during the lockdown browser, you're gonna have to show me all of those, and it will ask you to do that just like we did on the midterm. Then Thursday ends, and then Friday begins, and then the exact same test content will be released to you in a different assignment. And in that one, you won't have to use Respondus for. You can access it all day that day, and you can collaborate. So I'm okay with you talking to other people in the class. Don't talk to anyone outside the class. Don't talk to Chegg. Don't talk to Course Hero. You got to keep it in the class. But otherwise, you can use your notes from the class. You can use your Canvas materials from the class. You can use the textbook from the class, and you can talk to your peers from the class. And but I'm asking you to only talk to peers from your exam group. And so you can see your exam group again in that peoples and groups, because you know, for academic integrity, you know, I want to make sure that everybody's got a fair shake at it. And so please make sure that you're talking to someone within your exam group if you do start collaborating with people on Friday. And so that is the basic structure for Thursday, Friday. It's the exact same thing goes on Monday, Tuesday for those of you in the late group. So that's, I think, all of the administrative announcements. Are there any questions about that before we move forward to any technical questions that you have?
One really quick other logistic question. This exam is comprehensive, right?
Yes, that's right. This is going to be a comprehensive exam over all of the units.
Okay, just checking. Thank you.
There is a question about how many questions are on the exam. I don't know for sure yet, but because I haven't built all of the exam, but I can tell you there is some sample exams from, I think, the last semester, and it is probably going to be very similar to that sample exam. The sample exam, last semester's exam, or fall of, I think I taught this last fall of 2018, was a Scantron exam. So it's a kind of a similar format to Canvas, not identical, but very similar. And so that it would probably be a good model for the length and the types of questions that you would expect on this exam. Ideally, I'm giving you 90 minutes. So ideally, what it's designed so that everybody should be able to complete it within 75 minutes. I'm giving you 90 to account for any technical difficulties. I try to design the exam so that the average student ends in about 50 to 60 minutes. So some students are going to take a little longer. Some students are going to be shorter. Some of you will be done in a half hour. But I'm aiming for 50 to 60 minutes for the average student. And again, look at that sample from fall to get an idea of roughly the length. So are there other questions about the format? Is there a time limit once you begin stage 2? Great question. Stage 2, you got all day. There's no time limit. You just begin it and you can come back to it. You can start at 8 a.m. And you can reach out and say, hey, I had really problems with problem 7. Did you get problem 7? And then if you talk to somebody about problem 7, you both figure out problem 7, you go to lunch, you come back, you find somebody else to talk about problem 12 with. So stage 2, it's just, you got 24 hours to work on it all the day that you want. Or if you felt really confident about your answers on stage 1, then you could just go into stage 2 and then just, you know, tick off all the same answers. Now, you're not going to be able to see your answers from stage 1. And unfortunately, I also am going to hide your stage 1 scores because it occurred to me that those of you who do really well on stage 1, effectively, if you get your score shows that you did really well, then your memory of stage 1 becomes a solution set, and that's not really what I wanted. So, so your scores from stage 1 will be hidden from you. But you'll have your memory of stage 1. And so you can go back when you do stage 2. And if you don't really want to bother with stage 2, just answer all the same questions the same way. In fact, what I might recommend you do is write down your answers from stage 1 on your scratch paper, so that if you do want to see what you answered, then remember that the order, like there's randomization that goes on, but the randomization isn't in question number, it's in the solutions to every question. And there might be numerical randomization as well, but at least for like the multiple choice ones and things like that, then you can make a quick note of, you know, what you did on each one of those, and then that might help you in stage 2 to see if you want to keep your answer or change to a different answer. So there's a question. You could theoretically. So there's a question. Could you do theoretically worse in part 2? Theoretically, you could do worse on part 2, but keep in mind that 80% of your score is from part 1 and 20% is from part 2. So don't think of it as doing worse. It's almost like you have 100% for the final exam. In stage one, you're doing the first 80%. And in stage two, you're doing the next 20%. So if you did worse on stage two, then that just means that instead of you're adding less to that. So you're filling out the 100%. Well, I'm not taking the average of the two exams. I'm adding them together in this weighted combination where it's 80% times the first one and 20% times the second. All right, so any other questions about the format of this? I'm not saying it's perfect, this two-stage exam thing. This two-stage exam thing is this kind of new crazy thing in the academic literature that people are trying. They're doing it in different versions and variations. To me, this is my first time. Again, it may not be perfect, but it was my ways to approximate a makeup exam without actually having a makeup exam, period. Any other questions about the general outline of things? The other announcement I should probably mention that I'll put here and then happily open it up to technical questions about Pigouvian taxes or whatever you like, is that the course evaluations, I think, turn off on December 4th. And I thought the last time we had 22% of students so far. It's nice when it's at least is 50% or so. So if you have a chance to do the course evaluations, the link is on Canvas, that's great. If not, that's fine too, but it is, valuable feedback to get back from that. So just as a note that I think those disappear December 4th. It's a little awkward because, the final exams are now before the course evaluations, and it always before they were tried to make the course evaluations before the final exams. I guess that was to prevent retribution from students, or I don't know. But it's a little weird now that your course evaluations are actually after you've taken all of the course material. But I'm not too worried about that, but I just wanted to remind you that those are out there. So there's another question in the chat. Wasn't the two parts originally set up since the exams had to be done by the 4th? Now that we're trying to take them until the 8th, couldn't there technically be retakes? That's an excellent question. Couldn't I have made a retake? And in theory, I probably could have given you a second retake, but I am pushing the letter of the law right now. The provost came down and said nothing. There can be nothing due during finals week. That is innovation week, and you cannot prevent students from focusing on innovation week during the normal finals week. So we were told very explicitly, no, nothing can be due that week. They have to have the option to get everything done this week. And when people asked, what if all of the students agreed in a class that they would just rather take the final during finals week, we got a hard no. They said, you cannot do that. That is weird. The finals have to be done during this week right here. So I am bending the rules a little bit with this late exam. I think if someone were to send this up the flagpole or whatever, I bet somebody would say, well, actually, we can't let you do this, even though you're allowing people to take it during this week. My argument is, which I couldn't make with a retake, is that I am giving everyone the same opportunity to perform the same, just as well by the end of this week. And so it is okay that I'm providing an option into next week. If I gave a retake next week, students that decided to participate in Innovation Week fully wouldn't be able to take that retake, and they'd be at a disadvantage. And the provost said specifically, we do not want students to be in that situation. So that's why I didn't do a retake. Technically speaking, I think they could probably tell me I'm not allowed to do what I'm currently doing, but I'm not asking in the hope that what I'm doing is flexibly stretching the rules enough to not break them. But I really don't want to ask, because I'm afraid if I ask, they'll tell me I have to have everything this week. All right, any other questions about general formatting questions? Or, we can start into the technical questions here. I'm happy to toss up a scratch pad here. so that we can work things out. Great. Yeah, I'm glad that it's helpful. It wasn't that much extra effort on my part to just put it the second week. I worried a little bit about, well, now we have students that potentially could see the exam, early, but I hope you guys understand that those of you who elect to take it early, there isn't much curving in this class, but there is a little bit of grade boundary, adjustments at the end to make sure that we have nice, discrete grade, boundary things, and it's always going to benefit people. But in the end, it's going to benefit you if you take it in the early group to kind of keep all that information to yourself. So if you're taking it in the late group because you're hoping to get information from the early group, I hope that's not the case. I really hope those of you taking the late group are taking the late group because it just works much better with your schedule, and you'll collaborate with people in the late group, and the people in the early group will collaborate with people in the early group, and everything will be fine. So that's the spirit of it all. All right, so with that, maybe I'll bring up a sheet of notes here so that I can work any examples that you might like, or otherwise there might be general questions, or maybe I'll write, take some notes here. So just give me a second to share from this device. Which involves changing template here. Okay. All right, just one more second. For some reason, it disconnected me between those things. All right, so, questions. Do we have any questions? Okay, let's look in the, I also going to put up this meeting pulse. While I read through this question, I also want to bring up this tab. If you would prefer not, if you prefer an anonymous question, then don't forget you can always go to this link here, which I will put in the chat as well. And that, as a reminder, is a meeting pulse link that allows you to send me an anonymous question that will pop up on my second monitor over here, so that I can take that question there if you just don't want to volunteer your identity there. Otherwise, in the chat, I've got some questions here. I think the first question I have is, can we go over question 7 from homework D2? So let me bring that up on my side so that I can see what the heck question 7 was. So question 7 from homework D2, that was so this is a question, I'll just read the opening of the question. This is consider the efficient intertemporal market equilibrium for the non-renewable resource described earlier in the assignment. As above, you may assume an interest rate of 10%, and you may assume all the resource that is not supplied this year will be supplied next year. And so this is the problem where we are, it sounds like we're just working through a non-renewable intertemporal efficiency problem here. And so with that one, I guess so are there specific questions about, because this is a multi-part question, are there specific questions about problem 7, or are you just looking for me to work the example just to see that example again? I think that was to Madeline.
It was specifically the problems in there involving the marginal user. Oh, I forgot what the C stands for.
Cost, marginal user cost.
Yeah.
Okay.
It was mainly those two, and then.
Okay, so that problem, let me see if I can manage to short circuit some of the other stuff. There's one of these things where you know, you kind of have to do the whole problem to do some of the problems. And so just to remind everyone, this was, so problem 7 on homework D2. And this is one where we said that there are a total number of 20,000 units as a particular non-renewable resource, let's say oil. There is a marginal cost of $100 per unit. So you can think of that as $100 per barrel. There is a marginal benefit of 250,000 minus 20 Q, where Q is the current quantity supplied. And that is, you know, that marginal, you could view that as dollars per barrel. And so all of those things together give you a marginal net benefit, which is just your marginal benefit minus your marginal cost of 250 or 249,900 minus 20Q. And I just did the subtraction there. And I said that there is a discount rate of 10% or 0.1, which corresponds to a marginal rate of substitution with the future of 1 divided by 1 plus 0.1, which is 0.91. Well, it's about 0.91. And so in this problem, we had to solve for the dynamically efficient allocation. And so just remember that the dynamically efficient is when you've got the marginal net benefit evaluated at the year 1 quantity is equal to the marginal rate of substitution times the marginal net benefit evaluated at next year's quantity, which is T minus this year's quantity. And so we plugged in, and I'm not going to go through all the math, but I will, just as a reminder, plug, you know, say, well, on the left-hand side here, we'll have 249,900 minus 20 Q1 star. And on the right-hand side, we'll have that beta 0.91 times this quantity, which is going to be the 249,900 minus 20. But now we multiply by this quantity, 20,000 minus Q1 star. So it takes a little bit of, you know, you have to distribute everything through, solve for Q1 star. And what you'll end up finding is that Q1 star is equal to 10,118.34. And the price for every unit in the current period is just going to be the marginal benefit evaluated at Q1 star. And I go up to my marginal benefit, which is up here. And that, so I'm just going to plug in this 10,000 into this up here. So that's the 250,000 minus 20 Q1 star. And if I do all of that, then I end up getting a price per barrel of 47,633.20. So as you can see, this is far greater than the cost of extraction. So the marginal user cost for this year is going to be this extremely high price minus the marginal cost of extraction at that quantity. And this marginal cost is fixed at just 100. So the marginal user cost in that first year is going to be 47,533.60. And so that is everything I needed to know from year 1. So then I need to solve it for year 2, and then then I might be interested in the questions about how the marginal user cost changes from year 1 to year 2. So I think that's kind of where that question came from. And And I did see the question go into Meeting Pulse, and I see the other questions in the chat. Just want to let you know that I see those, and we'll come to those. So what I'm going to do then is do the year 2 variety, or the year 2 expression. So I'm going to go to a new page. So then for, so again, this is just continued problem 7 from homework D2. And so for year 2, the quantity in year 2, well, that's easy. That's just T, my total, minus the quantity from year 1. So that is my 20,000 minus my year 1 quantity, which is that 10,118.34, which gives me 9,881.66. So that's the number of units sold in year 2. Note that because there is a discount rate, a small discount rate, instead of selling the same number of units in this year as is next year, I sold more units this year than next year. So that 20,000 didn't get split 10 and 10. It got split so that I sold 10,118 now and 9,881 later. And the reason for that asymmetry is that there is a discount rate. I value my money now more than I value later. So that means I sell a little more now than I do later. But because I do value money later, I still sell some later. So if my discount rate was 100%, I'd sell none later because I don't value anything later. It's just best for me to sell it now. If my discount rate was 0%, then I would split things equally. I would sell the same amount now and the same amount later. All right, so that was Q2. So then how much does it cost? Well, I just plug into that same marginal benefit function, the Q2 star, which is going to be that same 250,000 minus 20 times my new value, 9,881.66. And then that gives me a blistering price of 52,366.80, and that is again per barrel. So the MUC, the marginal user cost or scarcity rent in year 2 is that price minus the marginal cost in year 2. And the marginal cost of extraction is fixed at 100, regardless of how much I extract. So I get 52,266.80 for my marginal user cost in year 2. So those are my 2 marginal user costs, and kind of the, and so, you know, at this point in problem 7, I think asked you to calculate the present value of the marginal user cost in the next year. So basically I said, if I know this is going to be the amount of extra money that I'm going to make above my costs, so this is the money that, this is my money, this is how much I make, this is profit. That's the profit I'm going to make in year 2. What's the present value of that now? And what I did with that in part G is I just took that that marginal user cost from year 2, and I then scaled it. I basically discounted it by 1 plus 0.1. This is just equal to beta. And so that gives me 52,266.80 times the whatever that was, 0.91-ish. And this here ends up giving me 47,415.27. And so this is the present value of the marginal user cost from year 2. And then in the last part of that question, I then noted that the present value, this value here, is, you know, practically equivalent to MUC1. And that MUC1, if I go back to the previous, is 47,533.60. And that's expected because the, the dynamically efficient equilibrium is one that, that makes the marginal user cost rise with the prevailing rate of interest. And so if I start with this much MUC this year, then I would expect that next year I'm going to have this much times 1.1, which is just the interest rate. I'm basically going to add 10% interest to it. So if you add 10% interest to this value, you get MUC2. So MUC1 ends up rising to MUC2 at the same 10% interest. And so that's basically what I'm trying to communicate here, is that there is a 10% increase from 1 to 2. And that is the no arbitrage condition with the bank. If I have done my non-renewable resource management right, then the asset growth of the non-renewable natural resource, so the natural asset growth, will be perfectly balanced by the monetary asset growth in the bank, so that I just leave things as they are, where I have this schedule of extraction, which is going to constantly give me 10% out of my natural resource. And then the money that I make from my natural resource, I just shift it on over into the bank, where it continues to make 10%. So that's the beauty of these natural resources, is you kind of dial your own interest rate, and then you can lock in an interest rate, kind of like a fixed rate mortgage, where then you turn that natural resource into money and then put the money in the bank, and then it holds that interest rate at the bank from then on out. Something that I hope you've had more practice now that we've gone through the forestry stuff. So I think I've waxed on enough about that problem. Are there specific questions or responses to this problem? Did this answer the questions that you originally had when this problem was brought up?
Yeah, I got a question, Professor. It's for the first part of the question. Could you go back to the slide? It went a bit fast for me for a second. How'd you get Q star 1? How'd you solve for that again?
Q star 1. So then this is just the expression for, this is the intertemporal equimarginal principle. And so I had to solve for the marginal net benefit, which I got the formula for up here, which is just the formula for marginal benefit minus marginal cost, this thing. And so I took that formula and I plugged in Q star 1 into it. And that's what I've got right here. And then I took that same formula and for Q, I then plugged in T minus Q star 1. That's what I've got here. And I multiplied it by my marginal rate of substitution at 0.91. And so that set up an expression down here that only had one unknown variable, Q star 1, and I could just solve that expression.
Okay.
Okay. Any other questions about this problem?
Yeah, in the homework it asked for like the scarcity rent, and I didn't get that.
The scarcity rent is just another name for the marginal user cost, and so the MUC1, this here is also known as the scarcity rent in year 1, and the MUC2, this here is the scarcity rent in year 2. And just to help, so why do we have all these different terms? And I think I posted a discussion post about this. The term rent just generally means the amount charged over cost. And then if we think about non-renewable, if we think about extraction of resources, so extraction of resources, then the price of the resource has two components. It has the marginal extraction cost, and then it has an additional component, the marginal user cost. And so this is sometimes known in the literature as MEC, and this is MUC. And we have just been, to keep things simple, calling this MC, marginal cost, where this is the marginal cost of extraction. But if we get into more formal literature, then they actually, focus specifically on extraction, and they call it MEC, marginal extraction cost. And so the price that people pay is they are paying for the extraction, the MEC, plus this additional component, which is also known as the scarcity rent. And it is known as rent because it is, by definition, right here, it is the cost above the cost of production. The cost of production is the extraction cost, and so this must be the rent. And why do we have a rent? In this case, we have a rent because scarcity ends up generating this increase in price over time. So that's why the shorthand name for marginal user cost is scarcity rent, but they are synonymous. If you hear me say marginal user cost, you can think in your head scarcity rent and vice versa. Any other questions about that? If I were to teach this course from scratch without the textbook, I probably would use these terms. I didn't use MEC because the book doesn't talk about MEC, and I wanted to make sure I was as consistent with the book as possible. I apologize for any confusion that generated. It was a judgment call, and so I decided to stick with the book's MC. The downside of that is then it makes it weird to think, well, what the heck is a user cost? Where does that come from? And it's meant to contrast with an extraction cost. All right, so then if there's no other questions from that one, then the next one I see here, I saw before the meeting pulse ones, was question 7 from D7, which I think I can do pretty quickly. So let me bring that up to make sure I'm remembering the right question. So now we'll flip to question 7. On homework D7. And that one was, I want to sketch the density dependent regeneration rate, F of X, for a simple fishery under logistic growth conditions. Let's do that first. So I just end up drawing a little axis here where it has the fish population here. That we'll call X, and then it has fish per year. So this is the regeneration rate. Well, it's in units of fish per year, but then what I'm going to draw is the regeneration rate. And so I am going to put in a carrying capacity K here. That is the most amount of fish that can be sustained, not sustained. I'll say that is, yeah, I could say the most amount of fish that can be sustained in this fishery due to resource limitations, food, etc. So I can then draw a F of X curve, which looks very similar to the yield effort curve. Something like that. And so this here is my F of X regeneration. And the point at highest regeneration rate is the, I'll call this X MSY, which is the maximum sustainable yield population. And note that note that X MSY is around half of the carrying capacity. That's just generally is the case. Sometimes it's a little less, a little more, depending on the shape of this curve, but usually this curve is symmetric, and so it's usually about half of the carrying capacity. And so I guess I should write that this is the carrying capacity. So this was the first part of that problem, just to draw this curve. Then on the curve, indicate the steady state populations that correspond to no harvesting effort and the maximally sustainable harvesting effort. And so the no harvesting effort case is, so if I have no harvesting effort, so there's no boats, then my fishery will reach steady state at carrying capacity. So the E equals 0 case corresponds to a steady state population of the carrying capacity. But if I instead put the maximal amount of effort out there possible to maintain sustainability, then that E, which I will call here E star, or I could maybe call E star MSY, then that effort corresponds to a steady state population of this population here. And hopefully not surprisingly, that then corresponds to the largest regeneration rate. So if I put the most amount of boats out there to be sustainable, I am going to end up coming to a steady state population that produces the most amount of new fish per year. But that's as far as I can go. If I put one more boat on the out there, then I'm biologically overfished, and so that will not be sustainable. And so all I'm trying to get you to see here is that on this graph, there's kind of, it's almost like the effort axis is reversed. So this is the E equals 0 axis, and this is the E equals E max sustainable, right around here. And so the lowest population of boats corresponds to the highest population of fish, and the highest sustainable population of boats corresponds to a population of about half of fish in there. And so that's all I was looking for there. So are there questions about that one? All right, that was question 7. Then I see in my queue, if I answered them in order, there's a question about 6 and 5, and then there's also in the meeting pulse questions about number 3 and number 2B on homework 7. So I see a lot of questions about homework 7. So I think I'll go to question 6 next. So question 6 on homework D7. And so here is, I think, another drawing thing. Using a hypothetical yield effort and cost effort curves for a private, simple harvested fishery in steady state, provide a graphical argument that the economically efficient private harvesting effort will always be sustainable, i.e. will not be overfished. All right, so in this one, we draw axes similar to the previous axes, but having different things on them. So in this case, I now plot my effort, E, I think this is number of boats. And then I've got my, this still is like a fish per year. Well, no, sorry, it's a dollars per year. I apologize, not a fish per year. So this is a dollars per year axis. And so there is a yield effort curve, which maybe I'll have the, I've got some maximum, and I'll draw a yield effort curve. It's not a great yield effort curve, but I think it'll suit my purposes for this question. And so I'll mark that as a yield effort curve. So just to make it clear, for this many boats, this curve tells you how much money you're going to make per year. if you're deploying this many boats per year. That's what the yield effort curve does. So as you add the number of boats, you're going to make more and more money per year until you reach this point, which is the maximum sustainable amount. And so at this point here, the regeneration rate of the fish cannot keep up with the boats that you're adding. And so any additional boats that get added, you're going to end up just accumulating the cost of the boats because you're not going to get any added benefit from the fish. And so that's why eventually you hit a point where you add so many boats to the fishery that you get $0 in return, because the costs of operating the boats end up not at all being compensated by the money you're making by selling the fish, because the fish regenerates so slowly. So this over here corresponds kind of to the extinction event, where you've got no fish in the fishery, and so you're getting no returns whatsoever. And then this up here is when you've got half the fish in the fishery and they've got their maximum regeneration rate. So you're making the most amount of money possible. So the other thing that I need on here are cost curves. And so let me just mark that maximum sustainable effort. So up here, this point here is my maximum sustainable effort. And so that means that everything over here is biologically overfished. Now, where is economic efficiency? Well, in order to consider economic efficiency, I need a cost curve for my private fishery. So I'm going to draw a line. So I'm going to start out by drawing a line, an arbitrary line out here. And so this is a cost effort, or CE curve, where the slope of this line is the per boat cost. So every new boat adds to the cost. So if I increase my effort, I'm going to add to the cost, and it's going to keep increasing along this line. And so we know that the economically efficient solution maximizes the distance between these two. So there is there's a level of effort that maximizes the gap between these two, that maximizes the economic efficiency. And there is a quick way to find it graphically, is to just take a line. I'm going to copy this line. This always happens the first time I do a paste in GoodNotes. I think maybe I'm just due for an upgrade in tablet. So if I take a line of the exact same slope and I shift it up and find its point of tangency, then that point of tangency, which let's say is right around here, that is my economically efficient solution. And so this, if I were to highlight, this distance here is maximized. If I were to add a little bit more effort, that highlighted segment would get smaller. If I were to take away a little effort, that highlighted segment would get smaller. So that is the maximal distance between the benefit and the cost, the maximal rent, if you want to view it that way. So we get the max rent out of that by doing it there. Okay, so the question is, what's a graphical argument that shows that this will never be biologically overfished if we always operate at the economic, at the efficient level here? Well, I hope you can see that if I increase the cost per boat, so that is just going to rotate this cost curve this way. So this here is increase cost per boat. And so that is going to make the slope of this higher and higher, because it's going to increase more and more. And so if I were to draw the parallel versions, then it's going to keep pushing this economic efficiency point down farther, so that it moves away from the maximum sustainable yield effort. So then the question is, well, what if I go the other way around? What if I make it super cheap to, what if I make it really cheap to fish? So this is decrease cost per boat. Well, in the extreme case, then I'll maybe use a slightly different shade of red and make this thick. Down here, I'll make it even thicker just to make it absolutely clear. This down here, that is the CE curve when boats are free. In other words, when the marginal cost is equal to 0. And so if I use this graphical argument, then I need to say, well, then what would the economically efficient effort be in this extreme case? Well, if I just take this line here, so I don't even need to necessarily highlight. If I just draw a line parallel to that, I'm just looking for a horizontal line. Where is a horizontal line tangent to the yield effort curve? Well, it is right at the point of the maximum sustainable effort. So it's right here. So E MSY corresponds to E star in this case. And so the graphical argument that I'm trying to get you to, and that I think the book talked about, but they didn't show, is that as you rotate the cost curve down this way, then you can show that the limiting case is a horizontal line. That is the cheapest cost curve. And in the horizontal line case, the point of economic efficiency is going to be right here. It's going to be at the MSY. So that implies that if you do the economically efficient thing, you will only be using effort on this side of the MSY. You will never crowd into this region over here. You'll only be on this side, so it'll be sustainable. Does that make sense? Is that helpful? Any questions about that? Okay, so let's see, there's also a question about question 5. That's one that I can do pretty quickly. So I could even borrow this curve, but let's just, question 5 is also about a yield effort curve. So I'm gonna redraw that yield effort curve. So I'm gonna swipe away from this just to redraw it. And so I've got, and my axis is gigantic, so I'll try to turn that off. So here, this is effort. This here is dollars per year. I will have that maximum effort over here. And so that's right around here is going to be so this is again a yield effort curve. And we know that this point up here, this corresponds to the maximum sustainable yield effort. And so we know that this region over here is biologically overfished. And so the question was, sketch a yield effort curve and a cost effort curve for a simple harvested fishery and steady state to show where the open access equilibrium is economically but not biologically overfished. And so the idea here is that if you think about these cost effort curves, the kind of typical one we draw looks like this, where it has an open access equilibrium over here, and this is clearly biologically overfished. But as you make the cost of boats higher, then you find that the open access equilibrium moves closer to the region where we would prefer it to be in. So as we keep making this cost higher, then the open access equilibrium, where the total cost is equal to the total benefit, starts moving closer to this biologically, to this point where we start this point of sustainability. And so the solution to this one is to draw an open access, or to draw a cost curve, which is so steep that the open access equilibrium is to the left of the MSY point. And so this here is the open access equilibrium. And just for kicks, I could also calculate the economically efficient one. And so I'm going to take this, copy it, and then paste it, and then move it over here to find the point of tangency, which looks like it's about here. So you can confirm that that maximizes that distance. So this right here is E star. And so now we can see that EOA is greater than E star. So that's economically overfished. But EOA is less than EMSY. So it's sustainable. So it is not biologically overfished. And we get that just by having, we could view this as very expensive effort cost. Or you can think, boat op cost. Other questions about that one? Does that make sense? It's just, basically I between 5 and 6, my goal was to get you thinking about rotating that cost curve up and down and thinking about where the point of tangency moves and where the intersection point moves. And so you should always kind of be thinking about, this tangency point and this intersection point, and as the cost moves relative to the yield effort curve, it drags these things around with it. And that's all that those two questions are doing in 5 and 6. So any questions about, and I guess I should note, I'll just write up here that this is question 5 on homework D7. Does that make sense? Then let me shift over to the meeting pulse. So the first question I got on the meeting pulse here was, can you elaborate on your explanation on Slack about number 3 on homework D7? All right, so question 3 on homework D7. I think my comment on Slack, so question 3 on homework D7, if I remember correctly, and please correct me, you can do it if you like on the meeting pulse. If you want to be anonymous, that's fine. I believe on Slack, I said for A through E, you can just use this quantity R times S minus D over P minus C. And the idea is here you have 5 variables, and you see what effect do they have on this quantity. The opposite direction effect will occur with optimal rotation length. And so the idea here is for A through E, I basically asked you about all 5 of these variables, all 5 of these parameters, the interest rate, the site value. So just to confirm, this is interest rate, this is site value, this is cost of replanting, this is the price that consumers pay for the wood, for the timber, and this is the cost per unit of timber to you to actually cut it down. And so I asked about all 5 of those in A through E. So F was the harvest value, so that was slightly different. So for all 5 of those, we can evaluate what happens to this quantity. If this quantity goes up, then the optimal rotation length will go down. If this quantity goes down, the optimal rotation length will go up. So if I want to do one quick example, let's say that the site value. So example, site value S increases, which I believe was, this is 3 cost of cutting oil, 3E. And so if the site value increases, then the numerator in this thing is going to grow. And so that means that the quantity above increases too, which implies that the rotation length decreases. And that makes sense because what we're basically saying is that if the site value increases, then the same growth rate will equate to a lower interest rate in our kind of natural capital bank. And so by increasing the site value, we have increased the amount of principal in our bank account, but the trees still grow at the same rate. So if we are looking at the returns on the amount of principal we've got stored on our natural asset, then we need to cut at a point where we cut at a shorter point where the growth rate is faster. And so we end up cutting earlier because our natural assets interest rate more quickly falls to the money market interest rate. And so that's an example there where site value increases, why rotation length decreases. It gets a little complicated if I think about, well, what about example when the cost of timber increases. And so that I believe was 3D. And so that's a little bit more complicated because if C increases, that's going to mean that P minus C is going to decrease, which is going to mean that that fraction S minus D over P minus C, well, now I'm dividing by a smaller number. When you divide by a smaller number, then the fraction increases, which means that that quantity, that whole quantity up there increases, which means the rotation length decreases. And then if I think about it, does it make sense? The rotation length decreases, and it does, because what it's by increasing the cost of cutting down the timber, then if you remember that P minus C is a conversion factor that converts wood into dollars. And effectively, I'm saying that the same volume of wood is worth less to me. And so even though I'm getting a lot of growth in wood, I'm not getting as much growth in dollars because that P minus C value has now decreased. So that's what it's highlighting here. The P minus C value has decreased. And so in order for me to meet the bank's interest rate, I have to cut sooner at an earlier growth rate. And that is why the rotation length decreases. All right, so that was a question that was on the meeting pulse. Elaborate on my explanation on Slack about number 3 on homework D7. I hope that that helped. If not, please let me know. The other one that came up on meeting pulse was question 2B on homework D7. 2B, all right. So the question here is, would it be acceptable to say at the end of year 6, beginning of year 7, since at that point the growth rate drops below 0.2, My thought process is you'd want to cut at the end of 6, beginning of 7, so you don't experience a year where the interest rate is lower than that of the bank. I think your thought process there is correct, but there might be a slight difference in how we're interpreting that table. So if I think about question 2 on homework D7, then there was this table where I had like years 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then I had a certain volume at the end of each year, 1, 4, 12, 21, 39, 56, 70, 83, 90. And then there was the third column here. So this is the year number. This is the volume, so you can view this as T. And then the third column was an estimate of delta V in the next year. So at the end of year 1, we have 1 unit that has grown, and we are estimating that 3 units will grow in the next year. So that will be the return we'll get in the next year. So, so that way I put a 3 there. The 1 plus the 3 is what gives me the 4. So then at the end of year 2, we estimate a delta V of 8, and the 4 plus 8 is what gives me the 12. And so they keep on going down here. So 9, 18, 17, 14, 13, 7, and 2. And so these are my delta V estimates for the next year. And so if you estimate the growth rate, delta V over VT, then what we're estimating here is effectively the return on next year's growth. So we're viewing the VT as how much is currently in the bank. And if we wait 1 more year, then we're going to get an additional delta V. And so that's like the natural interest rate. And so for this first one, 3 divided by 1 gives me effectively a 300% interest rate. Now the question was down here about year 6, end of year 6, beginning of year 7. So at the end of year 6, we've got a 14 divided by 56. And that 14 divided by 56 is 25%. And then in year 7, we've got 13 divided by 70. And that is 18.6%. And so, and this might be what you were saying in your question. I didn't have the answer in front of me, but based on this, then what this tells me is that at the end, so I would cut at end of year 7 because I estimate year 8's growth to be slower than bank. And this is specifically question 2B. So that's why I would say for that one that I was looking for the answer of year 7 or end of year 7, because the estimated delta V for year 8 is going to be less than what I would get if I instead took that money and put it in the bank. All right, and I think that's all of the questions that have been submitted so far. Are there questions about those? Are those clear? Are there any pushback, any concerns or comments?
Good question. Sorry, I didn't catch the part why it cuts off at the end of year 7. I thought it would be cut off because I answered year 4, not year 7. Can you explain why it was year 7 again?
Yeah, so just to fill in this table a little bit more, like for example, in year 4, I've got 18 divided by 21, which is an 85.71%. And then remember our benchmark target is 20%. That's what the bank can give us. So that's from bank. And so we cut in the year when delta V that we estimate for the next year gives us less than what we would get from the bank. So for all of these all are better than the bank. But all the ones from here down, those are worse than bank.
Oh, okay. We got it. I totally left out the benchmark.
Okay. And so, so then there was a question, isn't year 7's growth also lower than the interest rate? Why wouldn't we cut at the end of year 6? Unless I'm doing my math wrong here, at the end of year 6, we have this much that we could turn into money and invest in the bank. And if we were to invest in the bank, then this amount of money would grow at 20%. But our biological model of growth tells us that we're actually going to get 14 units of growth out of this investment of 56 units in the timber. And so 14 out of 56 is actually 25%, which is better than the bank. And that's why I don't cut at the end of year 6. I wait to cut to the end of year 7. I'm effectively allowing for these 14 to grow during year 7 and then cutting at the end of year 7. Does that make sense?
Yeah, it does.
And then there were some extra questions in the end. I appreciate that. Thank you. But there was a question, I think, from Jeremy and Ava and Caitlin. So, when 3 students ask the same question, it makes me think that I worry that I'm doing something wrong. But that is my argument. And so if you see a hole in that argument, there is a little bit of confusion because of this yearly quantization. In reality, we wouldn't necessarily, fix things to be years. We can actually estimate these delta V's with like derivatives, like V prime. And then that gives us finer resolution, and it makes this rate, there's less of this like logical mumbo jumbo about, do I cut now or do I wait a whole year? Well, really, you're just waiting for the instantaneous growth rate to fall, but we're estimating the instantaneous growth rate. So I think at the end, so there's a comment in the chat, I think at the end of the year and carrying on to the next year is what I was confused. I assumed that it was because the growth rate in year 7 was lower than the interest rate we want to cut before year 7. And that's it. So in the outline of the question, I was trying to communicate, and maybe this is my bad but I was trying to communicate. I said that VT is measured at the end of the year and delta V is estimated at the same time. And then I say, delta V is meant to be an estimate for the upcoming year. And that's where this logic is coming from here. And so there might have been some confusion about the meaning of delta V. But I still think that what I'm saying is consistent Because I see this comment, I think at the end of the year, and carrying on to the next year is where it's confused. I assume that because the growth rate in year 7 was lower than the interest rate, we'd want to cut before year 7. And I think I view my intent in the way I wrote this question was to view this growth rate not to be an estimate of how well things were doing in year 7. It was an estimate of how well things are about to grow in year 8. And so we cut at the end of year 7 because we are not excited about the growth going into year 8. And again, if you go to the way things are outlined in question 1, I say that this number is measured at the end of the year, and this is estimated for the next year at the same time. So at the end of year 7, you say, how much do we have and how much do we estimate we're going to get next year? And at that point, you say year 8 is only going to give us 13. That's not good enough. We're going to cut now at the end of year 7. But when we got to the end of year 6, we said, well, we have 56 and we're estimating we're getting another 14. 14 over 56 is better than our interest rate. And that's why we let things grow through year 7. Okay. Well, I will look at the stats, and I just hope I understand that, and I'll look at the stats for this homework and see if there needs to be an adjustment made. And I guess then what I ask you to do is to look back at question 1 of that homework and how I wrote it, and see if you can see where I'm coming from there, just so we can make sure that we're both, at least, I want to make sure that the right idea was communicated, even if the language was a little confusing. So I'm great. That's good. It makes sense now. I'll take a look at these as they're graded and see if some minor adjustments need to be made. But for now, yeah, just make sure you got the idea down. So we are 4 minutes over, so I don't want to keep you any longer than this. And so let's give you guys just one last attendance opportunity to water down any misses you had earlier. So in the attendance question here, which I'll put the link in the chat, is just what is the last day that you can elect to put yourself into the later exam group? In other words, what's your deadline for clicking on people, clicking on groups, and then joining the later exam group? And I'll tell you, it's today. So do it today if you want to do it. And that's all I've got for you. So I'm happy to stick around for a few more minutes if there's any more questions. Otherwise, good luck. And it's been a fun semester for me, and look forward to seeing some of the rest of you in the future.
Yeah, Professor, I got one more question. Is regarding the exam itself. So I understand that it's gonna be regarding content from A through E, cumulative. When I look at if I'm gonna look at the solution sets for the final exam from like last fall, the amount they give us, are we expecting the same amount of answers, like this X amount of questions from like section A and like this amount of questions from like section E? Are we getting the same amount of those for this
good question.
Or is it different?
Last fall, I gave the final exam during finals week during a 150-minute period. So that is a longer exam than you would expect. But it's still cumulative, but there may be, the questions either maybe won't take you as much time or there'll be fewer of them. But because this exam again is designed for everyone to finish in 75 minutes, but I give you 90 minutes anyway, and the average student to finish in about an hour, 50 to 60 minutes.
Okay. All right. Thank you.
And thanks for the feedback in the chat. Go ahead.
I just had a question on how the final is inputted in Canvas and the grades. So I was trying to do that thing where you like figure out how much you needed on the test, but because of the 80-20, I couldn't figure it out. Is there a way to do that?
Absolutely. I just have been behind on getting things set up because it's this weird, but hopefully today I'll be able to at least put stubs in there so that you can do that calculation for you. And so then it'll show, and so I'll implement the weighting for you in Canvas, and then you'll see like stage 1 final exam, stage 2 final exam, and you'll be able to put in hypothetical scores and then see. And you might find that if you have a high enough grade in the course, it's just not worth it to you to even take the stage 2. So I will do my best to get that there as soon as possible. But of course, by Thursday, it'll be there because the actual exams will have to be there by Thursday anyway.
Awesome, thank you.
Yep. And there was a question in the meeting pulse, is the posted grade on Canvas accurate? It is accurate based on everything that you have submitted and everything that has been graded. And so it basically gives you your estimate of all of the points that are available and have been graded. That's your percentage weighted in the weighting that's as described in the syllabus. Now, the final exam is a significant chunk of your grade, and it is not in there. So that means that it's as if instead of dividing by 100%, it's like dividing by whatever, 80% or 75%. So that is going to give all of your other things like your homeworks a disproportionate effect on your estimated score right now. So if you do well on your final exam, not only will it bring your score up, but it will it'll push down the effect of some of the existing things there. But that is the best estimate that I can give you right now, is the one in Canvas. If you were to calculate it yourself using all my weighting, you should get the same thing that Canvas does, and all the dropping has already been implemented.
Thank you so much for such a great semester.
Oh, thanks. I'm glad it was helpful. So I will stick around if anybody has anything else.
Thank you.
Have a good day. Good luck. All right, looks like everybody's heading out. So ciao.